Hi, today we're going to do lesson 1.6, which is applications of linear functions, which is another fancy way of saying we're doing word problems today. We're going to be doing the first two examples of this lesson, so you only have two examples instead of three, and your homework will cover those first two examples that we're going over here. Example number one, new televisions have a 16:9 aspect ratio. The length of its rectangular screen is 16/9 times its width. If the perimeter of the screen is 136 inches, find the length and width of the screen. Okay, so one more time, the 16:9 aspect ratio, okay, that means the length of its rectangular screen is 16/9 times its width. If we knew the width, this problem would be pretty easy, because if I knew the width, all I'd have to do is multiply it by 16/9, and that would give me the length. So what we're going to do is we're going to actually take the width, and we're going to say, let's assume that it's x. Okay, let's make that x. And since that's x, that means to find the length, all we have to do is take the x and multiply it by 16/9. Okay, so we got 16/9 x is going to be the length. So here's what we're going to do. Okay, we're going to take this perimeter formula, which should look very familiar to you for a rectangle. You know, every rectangle has two widths, and every rectangle has two lengths. So we're going to fill in everything we can about this formula, and we're going to work it out accordingly. So they did give us on here that the perimeter of this particular rectangle, which is a TV, this perimeter is 136. They told us that the length worked out to be 2 times L, and the length from our picture turned out to be 16/9 times x. And we're also going to be adding on 2 times the width, and the width, according to our picture, turned out to be x. So here's what we're going to do. First, we're going to multiply these two together first, which is 2 times 16/9. So I'm going to bring down the 136. Remember, this is 2/1. That's a whole number here. Okay, so you have 2 times 16, which is 32. You have 1 times 9, which is 9, and you still have the x, and this is plus 2x. Now we're going to use the technique, a little more practice on clearing out fractions to work this particular question. So I'm going to go ahead and change colors here, and I'm going to ask if this one has a denominator of 1, and this one has a denominator of 9, and this one has a denominator of 1, what is the least common denominator? And yes, the answer is 9. So I'm going to go ahead and multiply the left side by 9, and I'm going to take and multiply the right side by 9. And we're going to see what we end up with here. Okay, so when we take 9 times 136, we end up with 1,244. Whoop, let me get this out of the way here. 1,224. On the right side, 9 cancels with 9. They both turn to 1s. And you have 1 times 32, which is 32x. All right, we also have 9 times 2, which is 18x. All right, I'm going to move this down just a little bit here. All right, so now at this time we're going to add up 32x and 18x, so that's 1,224 is equal to 50x. We're going to go ahead and divide by 50. And 1,224 divided by 50 turns out to be 24.48. So x turned out to be 24.48. Now x stood to be the width, okay? So that means that this is the width. All right, so I'll go ahead and put the word width here. And also in the directions, it tells you that these measurements are in inches. So here's one of our answers right here, okay? 24.48 inches. Now, if we want to know how to get the length, which I'll switch the color back here again, then you have to find the length, you have to take 16 over 9, and you have to multiply that by x. And x in this case is 24.48. And that turns out to be, which means we'll take 16 divided by 9, and we will multiply that by 24.48, and the answer is 43.52. And 43.52 again is in inches, and we're going to go ahead and mark that as the length. And this is our final answer to the question. So we have found the length and the width of this TV. Okay, so now we're going to go ahead and go on to the second question here. Okay, second example. I'm going to get to this one here. Here we go. This one says, example 2, how much pure alcohol should be added to 20 liters of 40% alcohol to increase the concentration to 50% alcohol? First of all, you have to read the question and figure out what exactly you're looking for. At the top it says how much pure alcohol should be added. So very simply, okay, when I go to this first part here, let X represent the, oh, look at that. Let X represent the number of liters of pure alcohol to be added. The number of liters of pure alcohol to be added. So go ahead and write that down. Let X represent the number of liters of pure alcohol to be added. Okay. All right, so what we're going to do is we are going to take this little diagram here of 3 rectangles. And you can think of these as buckets. You can think of them as beakers from your science class. But we're going to take these and pretend this is one of the mixtures. We're going to add it to a different mixture, and we're going to see what we end up with here. Across the top of this, we're going to keep this all the same. This is what you're going to do in your homework also. This is all liters of liquid all the way across, and the bottom of it is going to be our alcohol concentration. Now, when you do your other examples, it may not be alcohol. There may be other things, they talk about, saline, or they might change the type of liquid itself. But these problems all generally work the same, but they do have little tweaks here and there. Liters of liquid. First of all, I'm going to start with the one we know everything about. This one has 20 liters, and it has 40% alcohol in it. So this particular one, we have 20 liters. And down here is going to be 40%, but we know that when we use our equation, we're going to have to use 0.4 or 0.40. In the second one, we're going to be adding in pure alcohol, okay? And the question is, how much pure alcohol is there? Well, X represents the number of liters of pure alcohol. So this is the liquid across the top, how much of that liquid there's going to be, and we don't know. So that is going to be our X. But the real question is the percentage down here, because we do know that. We do know that. It says how much pure alcohol. What is pure alcohol? What is it? How much, does it consist of? Is it 40%, 50%, 60%? It's pure. That's right. Some of you are probably saying it right now. It's 100%. And 100% in mathematics, and you're going to let the number 1 represent that 100%. So now you got to make your mixture. First of all, we're mixing a 40% with 100%. That doesn't mean you're going to get 140%, okay? In fact, you can't even get above. You can't even get to 100% when you start mixing these together. There's stuff in here that's not alcohol. When you mix it with 100%, it's still not going to be 100%. So you'll never get above the biggest percentage. That should be a little hint for the first problem that you're asked in your homework today. But over here, you wanted to end up with 50%. Okay, 50% is what it said up here we'd like to end with. But how much liquid did we end up with? We're putting together the first, you could say, beaker with the second beaker to get a total, amount of liquid. And that would be 20 plus X. So we ended up with 20 plus X. And we're going to go ahead and we're going to write our equation now. Okay, we did the hard part. The hard part of this is completed. What we're going to do is take this information and we're going to write our equation. We know that to use percents to figure out how much of this is alcohol, there's 20 liters, 40% of it. To figure out how much there's alcohol, we're going to go ahead and multiply. We have 0.40 times 20 plus, we have 1 times X, which is 1X, or you can just say X if you want. And that is equal to 0.50 times 20 plus X. All right, so we have to go ahead and solve this particular equation. 0.4 times 20 turns out to be 8. 8 plus X is equal to 0.5 times 20, half of 20 is 10. We have plus, distribute the 0.5, so we got 0.5X. And let's see, we also got to get our like terms together, so we'll go ahead and, subtract 8, put our numbers together that don't have X together. X equals 2 plus 0.5X. If I can write the X here, I'm going to fix that there. Okay, and I'm going to move this down just a little bit more. We're going to go ahead and subtract 0.5X and subtract 0.5X. And you got to remember that there is a 1 here, so 1 minus 0.5 ends up being 0.5 again. So 0.5X is equal to 2. Divide by 0.5. Divide by 0.5. Don't forget that when you divide by 0.5, you're really doing a fraction. So I do want to point out that 2 divided by a half. All through middle school, you guys learned that instead of dividing by a fraction, you would multiply, and you would multiply by the reciprocal. And therefore, 2 times 2 is 4. So we ended up with an answer of 4. I'm going to go ahead and move this down just a little bit. And underneath this little yellow rectangle here, therefore, 4 liters of pure alcohol must be added. 4 liters of pure alcohol must be added to create that 50% mixture that we needed. All right, so now it is time for homework time. The homework will be put up onto the board. Have fun.